The final major concept in JavaScript fundamentals that I want to cover is asynchronous programming. So this will be more of a conceptual lecture with pseudocode rather than specific code examples. But I think it's a very important concept for both programming JavaScript on the client side in the browser and also server side in the back end. So asynchronous programming. So far, all of the code that we've seen has executed sequentially one line after another. Right, so your program ends when the final line of executed code finishes. It starts in the top, keeps on going. Maybe it has some loops, maybe it calls some functions, but there's a starting point and there's an ending point. And this is the case for, say, command line programs that you're running or little programs you're writing for classes and such. But in fact, a bunch of code that runs in the real world, including the JavaScript code that runs both in your web browser and on a web server, doesn't work that way, right? It doesn't just start running and then finish and exit, because if it did, then your web browser would open and the code would stop running and the web browser would close. Or your web server would start and then it would run all of this code and then it would just close. So that's not useful for any sort of interactive program such as a browser or a game or some kind of program that needs to run and listen for requests coming in from the internet, like a web server. So both your browser and server, don't work in this sequential way that actually just runs code and exits. So conceptually, a web browser's JavaScript code must initialize the web page and then sit idle to wait for user input, such as mouse or keyboard events. And similarly, a web server's JavaScript code must open a connection to the internet and then sit idle to wait for requests to be sent to it. So even though these two are really different kinds of programs, they do very similar things at a high level, right? They do some initialization and then they wait. They wait for some kind of input from the outside world, such as from a user or from a network connection. Very roughly speaking, here's some high-level pseudocode. So this is not real code. So pseudocode for the browser is it first initializes the web page, calls some function and runs some initialization. Then it sits in a while true loop. So this is not really a real while loop, but it's conceptually like this. So it's like while true, we're going to check for user input. And if the input we call E, if it's a mouse, we're going to dispatch to a handle mouse event function. If it's a keyboard event, we're going to dispatch to a handle keyboard event function. And otherwise, we're going to, dispatch to other events, or we're just going to keep looping forever. So that's how when you get a mouse input or a keyboard input, this infinite loop will catch it and do something. And because this is conceptually an infinite loop, your browser doesn't exit until you say file exit or something, and that actually sends a signal to have it exit the process. Similarly, the server is really similar. There are some initialization functions, and then there's a while true loop that conceptually runs. And that while true loop now checks for HTTP requests, which are incoming network requests of a certain format that web servers handle. And then if there is a request, if R is not null, it handles the HTTP request. It dispatches onto some function to handle the request. And again, that just keeps spinning and waiting for requests. If there's no request coming in, it will just wait. It will just keep infinitely looping conceptually and just waiting until a request comes in. And again, your server gets taken down when you explicitly shut down the server or you shut down your computer. Okay, so I just want to show you the parallels between web browsers and servers. They both have this conceptual infinite loop. For both efficiency and software reliability reasons, both browsers and servers, for the most part, are implemented as a single thread of execution. So it means that conceptually it really is a single infinite loop and it just goes on forever. That's a pretty good way of thinking about it. So now let's think about a server scenario, because we want to think about the back end, but the same thing kind of applies to front end as well. So imagine that a client, such as a web browser, sends an HTTP request to the server. So what does the server do? The server looks at the URL parameters, parses the URL, maybe makes a database query because it's a server, it has a database, and then sends the data back to the client. So conceptually, here's what happens. It finds, it does while true, a request comes in, an HTTP request from the web comes in. it dispatches to the handle HTTP request function. So if we zoom into this function, the first line grabs some parameters, grabs a query, which is, the first parameter. It does a database lookup on that query. So database lookup is in bold because that's some database API function. Once it's done, it puts the result in a result variable, and then it sends data to the client. It just sends some data using that result. Okay, so let's zoom in on that function. So what if the database lookup function is really slow? Let's say it takes 5 seconds. What happens to the server? All right, because there's only a single thread, the server will hang there on the line that the database lookup query is executing. It's just like there's only one thread. There's no multi-threading. So it's just going to hang there and wait. That means that the server cannot handle any requests for 5 seconds. So if you have more people trying to make requests to the server, either, it depends on how it's implemented, either their packets are dropped or they're put on a queue and they have to wait until you're done. You have to wait until after 5 seconds. So that's clearly suboptimal because you don't want people to have to wait for so long. So what can we do about it? Well, let's go look at this code. I just zoomed into the handle HTTP request codes. Remember, this code is run whenever someone sends the server an HTTP request, some kind of request for data. So the first line is very fast. Let's say it's 0.001 seconds. It just grabs some parameter out. It's very fast. The second one is a really slow one, the database lookup. It's 5 seconds. And the third one, send data to the client, is fast. It's not that fast, but it's like 0.01 seconds. Let's just hypothetically make up those numbers. So the runtime is completely dominated by the database lookup, right? So this function takes over 5 seconds to run, which means that with a single threaded server, the server can't do anything for the next 5 seconds. And it's just waiting on the database. And that's really bad, right? So imagine if you have any kind of website with a non-trivial amount of traffic, you don't want to be waiting 5 seconds for a database. So what can we do about it? So as a thought experiment, how much time would this function take if it didn't need to wait for the database? Well, if the database lookup time went away, it would take 0.001 plus 0.01 seconds. It would take 0.011 seconds. It would be pretty fast, right? It would be way less than 5 seconds. So how can we kind of seemingly make the database lookup 5 seconds, quote unquote, disappear? Seems kind of paradoxical. How can we just make that time disappear? Well, one way we could simulate making it disappear is that we could let the server handle other requests while it waited for the database to finish. So that, remember, the database is some external application that's not part of our server necessarily. The server connects to it and queues up jobs in the database somewhere. The database is some complicated black box that does its magic. It just so happens that we have to wait for 5 seconds for it to do its magic. But what if the server didn't have to wait for the database and it could actually do other things while the database was crunching its numbers and doing its thing? Well, here's a way to do it. So here's the original code. I just shrunk it so it's smaller. Here is an alternate way to do this HTTP handling using an asynchronous programming style. So in the alternate way, what we have is we have a handle HTTP request function, that same first line, which is query, is to grab the query out, 0.01 seconds, exact same first line. Now the second line is a database lookup async function. So this is specially named. It's called an async or asynchronous function. It just has a special name. Now we're going to pass it not only the query, but we're going to pass it finisher. And finisher is the name of another function. It's the function we're going to run when the database query finishes. So if you actually look at the bottom to the finisher function, this is run after the database finishes doing its thing and passes it a result. And then we're going to send that result to the client, which is 0.01 seconds. So if you look at the top code with 3 lines of code and the bottom code, it has kind of those 3 lines, but it's split up into 2 functions. Now, those 2 functions are run at separate times. The finisher runs 5 seconds after the database lookup async runs. But the key is that the database lookup async function will return to the caller. It returns the caller right away so that it doesn't actually wait for the database. It just says, go, it just asks the database to do something, and then it says, whenever you're done, 5 seconds later, whenever, call my finisher function. In the meantime, I'm going to get out of the handle HTTP request function, and so my server can handle other stuff. Okay, so what does this database lookup async look like? First of all, you don't have to worry about it because the library creator writes it, right? Like somebody, in order to do asynchronous programming, the writer of the library or the framework has to write it and bake it into their library. So you as a user just use it. You don't have to worry about how it works. So database lookup async is pseudocode, takes a query and a finisher. And what it does is it first magically dispatches the query to the database and tells it to call the finisher function when the database finishes its job after, say, 5 seconds. Now, once that first dispatch is done, it says, hey, database, do something and call finisher when you're done. Then it just returns right away. This is the magic of the asynchronous programming. If I ask you how long does database lookup async take, it takes only, I wrote this down here as an estimate, as a made-up estimate. It takes only 0.001 seconds. Database lookup async finishes very fast. And it finishes very fast because the first thing it does is just tell the database to do something and tell it to call finisher when you're done. And then it's just done right away. So database lookup async returns right away to the caller.